Good. Okay, recording. All right, we are going to be talking about lesson 6.4, which is mid-segments of triangles and the triangle mid-segment theorem. Okay, so what we want to start off with is we want to start off with the definition of a mid-segment and the definition of a mid-segment of a triangle. Okay, what is a mid-segment? I want you guys to think about that word, mid-segment. Okay. So we should know that a segment is like a line segment, right? It's a line with a start and a finish. When we say mid segment, we're talking about a segment in the middle. But in the middle of what? What is the mid segment in the middle of? I don't know. Okay. Actually, I do know. You don't know yet. So I'm going to share what I know. I know, amazing, right? So the mid segment of a triangle is a segment that connects the midpoints. So it connects midpoints, okay, of two sides of the triangle. It connects the midpoints of two sides of the triangle. Okay, so if I have these two sides, it's connecting the midpoint of this side and this side. With these two sides, it's connecting the midpoint of that side and that side. So you can have up to 3 mid-segments in one triangle, right? So every triangle has 3 mid-segments, which form a mid-segment triangle. So they form a smaller triangle that is called the mid-segment triangle because it's made up of mid-segments. Okay. So in this diagram here, okay, the mid segments of triangle ABC are segment MP here. So this guy, okay, segment M, oops, MN, this guy, and segment NP, which is that guy. Okay. So what that does is that makes that makes triangle MNP, right? So then triangle MNP is the mid segment triangle. Triangle MNP is the mid segment triangle for that guy. Okay. And I want you guys to notice what's happening here. Okay. So if MP is a mid segment, right? If MP is a mid segment, that means M is the midpoint of AB. So that means this AM and MB are congruent to each other, right? That's what a midpoint is. It's the middle, meaning it's cutting it in half. So that means that AM and MB are congruent to each other, or they're the same measurement. And that means if MP is a mid segment, then that means P is the midpoint here. So if P is the midpoint there, then that means that BP and PC are congruent to each other because P is the midpoint of BC. Okay. And similarly, if NP and MN are both mid-segments, that means N is the midpoint of side AC. So that means N is cutting side AC into 2 equal parts. So that means AN and NC are congruent to each other. Okay. So a mid-segment, knowing that a segment like this exists, if you're told, hey, this is a mid-segment, right? Then you're essentially being told that each one of these triangle sides, this bigger triangle here of triangle ABC, each one of these sides is being cut in half. That's what you're being told, okay? Each one of these sides is being cut in half. Now, a triangle mid-segment has more properties than just connecting midpoints and the midpoints cutting each of the sides in half, which that's one of the biggest properties you have to remember, okay? You have to remember that the mid segment is connecting midpoints, right? And midpoints cut segments in half. So you have to remember that that we're talking about midpoints like we're talking chapter 1, right? So we still got to know midpoints. Now, we have an example. This is a bit of a proof, right? It says in triangle JKL, show that midsegment MN is parallel to JL and that MN is 1/2 of JL. Okay. Now, this is a very involved proof, and this is where your warm up comes in. Because in our warm up, I asked you guys to identify two formulas for me. Okay. I asked you to identify the distance formula, right? And I asked you to identify the slope formula. Both of which we're going to be needing here. Because in order to show that two segments are parallel to each other, we need to show that they have the same slope, right? And that's where the slope formula comes in. We need to show that they have the same slope. I'm going to zoom in a little here, okay? And then in order to show that MN is equal to 1/2 of the length of JL, right? For this, I'm going to need to know their lengths. So for this guy, I'm going to need to use the distance formula, right? To figure out what's the length of MN and what's the length of JL, okay? So first things first, I need to actually graph this triangle right here. So we're going to do J is at -6 and 1. Here's J, okay? Then we're going to do, I think we're missing information here, but I will give it to you, don't worry, okay? So here's J at -6 and 1. We have K at -2 and 5, so -2 and up 5, that's right here. Here's K. All right, and L is at 2, -1. So 2 to the right, down 1 for -1. So here is L. Okay, so I'm going to connect these guys for my triangle here. Oopsie. Okay, I'm going to twist my paper for a second so I can draw this well. There you go. All right. Okay. There you go. Now we are missing a small bit of information. We need MN, and I didn't realize that, but we do have, I'm going to give you guys the coordinates for M and N. So M is at, let me tell you that right now. M is going to be at -4 and 3. And N will be at 0, 2. Okay, those are our coordinates for M and N. So now I'm going to plot M and N here. You know what? I'm going to do that in red. Okay, so M, right, is our MN is our mid segment. So I'm going to plot that in red here. -4 and 3. So I have -4 up 3. We got it right here. Here is M. Okay. And N is at 0 and 2. That's right here. That's my N. Okay. And again, I'm just going to twist this real quick so I can make my straight line. There we go. Okay, I know it's not perfect, but it is what it is, right? So, okay, why don't you guys do this for me? When you're done graphing this, raise your hand in the reactions. Okay, when you're done graphing, raise your hand in the reactions so I know you're with me. Thank you, Maya. Thank you, Andres Leon. Thank you, Michael. Thank you, Mariel. Thank you, Jasmine and Destiny. Thank you, Joshua and Caleb. Thank you, Gabriel. Thank you, Heaven. Thank you, Jayla. Thank you, Joe. Still waiting for a good amount of you guys. Please raise your hand when you're done graphing your triangle and your mid segment. Okay, thank you, Samson. I'm going to give you guys about 30 more seconds to graph here. Okay. Just a side note, if you're one of those people that keeps saying you're not good at math and you choose not to take notes, that's literally the same thing as saying, I'm not good at basketball, but all you do is watch basketball. You never actually play basketball. So if you're not going to take notes and you're not going to participate, you literally have no right to say you're not good at math. Okay, you lose that option because you don't even try at that point. Okay. So 30 seconds are up. Let me just mark some participation stuff here for me. How y'all doing? Everyone good? All right. Just marking some participation points up in here. I don't know if you guys realize, I know I don't put in participation points like on a weekly basis, but I don't know if y'all realize how much participation points helped you at the end of the semester when I did put in that giant chunk of participation points. And some of you guys really shot up because of it, and some of you guys did not. And that's all on yous, right? Yes. Okie dokie. Thank you so much for your responses there and letting me know that you're with me. Okay, so back to this. Okay. So we have our triangle JKL. Our mid segment is MN. And we're comparing, notice we're comparing MN to JL. Okay. So excuse me, comparatively, if we're looking at MN and JL, right, notice which side JL is. So we're trying to see if MN is parallel to JL, and then if MN is half of JL, right? So we're looking at this guy right here. We're looking at this side, JL. So notice it's not the two sides that we're using on the mid segment. It's the side that we're not. It's the side that the mid segment is not touching at all, right? So we're comparing the mid segment to the side that's the third side essentially. So the first thing we want to do is we want to see if MN is parallel to JL. Well, for that we need to know if they have the same slopes. If they have the same slopes, then they are parallel. If they don't have the same slopes, then they're not parallel. So that means we got to use the slope formula, okay? Or we got to do rise over run. So we can do this two ways. We can do it visually, or we can do it with the formula. So the formula, if you guys remember, the formula is M is equal to y2 minus y1 over x2 minus x1, okay? Y2 minus y1 over x2 minus x1. Okay, so I have which one would you guys prefer to use? Would you prefer to use the visual method, or would you prefer to use the formula?
Visual means counting the little boxes on the graph.
Yes, it does. Thank you. Yes, visual means counting on the graph itself, like doing rise over run and then putting it. So we can just do rise over run if you guys want. You guys want to do that? Okay, we don't have to do it all algebra. We can bring it back to our visuals, right? Okay, so let's do rise over run for slope, right? M is equal to rise over run. That's our slope, okay? So let's find the slope of Mn. Okay, I'm gonna find the slope of Mn. I'm trying to find the slope of Mn. You guys cannot see what the heck that is down there. It looks bad. Okay, that's the slope of Mn. Okay, so what am I gonna do? I'm going to literally count. Rise is how much I have to go up and down, right? So that means over here, for starting from M, I go down one box to get to the level of N. So this is down one, okay? That's my rise, up and down. But I went down one, which means my rise is going to be -1 over my run, okay? My run, which is 1, 2, 3, 4. Okay, I went 4 to the right for my run. So if I went 4 to the right, that means it's a +4 for the run. So my slope for Mn is -1 over 4. Okay, my slope for Mn is -1 over 4. Okay, I used my rise over run visual method there, just counting the boxes. Okay, hopefully this is ringing a bell from algebra. Okay, next I want to do JL because I'm trying to see if Mn is parallel to JL, right? I'm not just trying to compare it to any. Someone have a question? Honey, you're unmuted.
Stop doing.
There we go. Okay. So now I'm going to do my slope for JL. So now we're going to do the slope for JL. Okay, and I'm going to do the same thing. It's again rise over run. So I'm going to count the rise. So to go from J to L, I have to go down 1, 2. So 2 brings me down to the level of L. Okay, since I went down 2, it's going to be -2 over, that's my rise. So now I'm going to count how many steps I have to go to get to L. So 1, 2, 3, 4, 5, 6, 7, 8. Again, guys, just a clarification because some kids tend to have this misunderstanding. When you put your pen on that corner, that's not 1, that's 0. When you take your first step, that's 1. Okay, so from here to here, it's 1, 2, 3, 4, 5, 6, 7, 8. Okay.
In other words, we're counting how many boxes you move your pen.
Right. So we have 8 here and we have 2 here, right? And it's a +8 because we went to the right. All right. Ooh, does that look the same? Does that look the same? Oh, Maya says yeah. Okay. Well, Maya, explain please. What can I do here? Yeah, I can simplify by 2, absolutely, right? 2 goes into 2 and 8. So if I divide by 2 on top and bottom, I get -1 over 4. Bam. They have the same slope. Both of these have the same slope. So we showed that Mn is parallel to JL. So we can say that Mn is parallel to JL because they both have a slope of -1/4. They both have a slope of -1/4. Okay, there we go. Bam. Okay, we just showed that they're parallel because we showed that they both have the same slope. Okay. Next, we need to show the distance one. Okay, so for this one, we're gonna have to use the distance formula. There's no way around it. There's zero way around using the distance formula, okay? We can't do it visually. They're slanted, they're diagonal, so they're not like vertical or horizontal for us to just count. So we have to use the distance formula. So if you guys remember, the distance formula, let me move this over here. The distance formula is x2 minus x1, close the parentheses, square that, plus y2 minus y1, close the parentheses and square that. Okay. That's our distance formula. Okay. So we're going to have to find the distance of both MN and JL to see if MN is half of what JL is. Okay. So for that, we're going to have to use the distance formula twice, those times. And we're going to go through this. Let's start with MN. Okay, where does this x1, x2, y1, y2 come from? It comes from the points. So if I take a look at my points M, which is at -4 and 3, and N, which is at 0 and 2. Okay? If I take a look at those points, I can label each one the x1, y1, and the x2, y2. So I'm going to actually use colors here so that you guys can see the difference. So I'm going to use x1, y1 for my MN. Here, since you guys can see this, I'm going to zoom in so you guys can see a little better, okay? There you go. Right there. Okay, so our first point is going to be x1 and y1. Our second point is going to be x2 and y2. Okay? So the ones are from one point, the twos are from another point. So how do I make this work for me? Well, whatever I labeled these as, I'm going to plug them into my formula here, right? So my distance for MN is going to equal, open my radical, okay, x2 minus x1. x2 is 0, okay, minus x1, which is -4, and close that to square it, okay, plus y2, which is 2, I labeled that as 2, minus y1, which is 3. Oops. Close that parentheses and square that. Okay. So I plugged in the x1, y1, and the x2, y2, and I'm just going to go through and I'm going to simplify this. We have minus and negative here, which turns this into a positive. So I have 0 plus 4. Okay, 0 plus 4 is 4. So I'm going to square that. Plus 2 minus 3 is going to be -1, or square that. So I keep going inside the radical. 4 squared is 16, plus -1 squared, that's -1 times -1, which is 1. Add those guys together, I get the square root of 17, okay? So I'm going to take the approximate square root of 17, and the approximate square root of 17 is un momento, por favor. The square root of 17. Okay, it is 4.12. We're just going to leave it at that, 4.12. Okay. So that's the approximate distance of MN. Now we do the same exact thing, but we're going to now do it for JL. Okay. So now we're using the points for J and L. J is at -6 and 1. L is at 2 and -1. God, crap. There you go. Okay, I'm going to do the same exact thing. I'm going to plug in. So JL is equal to square root. Open my parentheses here. Oh, oh, my bad. I'm sorry. I forgot to label my points. I forgot to, oh, that's not a good thing, right? Watch, this time, just to show, it doesn't really matter which point you label as x1, y1 and x2, y2. It really doesn't, okay? As long as the ones are together and the twos are together for the x's and the y's.
Just a reminder that 1, x1, y1 is point number 1. And the x2, y2 is point number 2. That's what the numbers are.
Yes, exactly. Thank you. Okay, so it really doesn't matter which one is the 0.1 and which one is 0.2. Okay, so I have my x2, which is 2. Okay, minus my x1, which is -6. We got another double negative here, which is okay because we know how to deal with those. We just got to make sure we're noticing them when we're putting them in, right? So then we have our y2, which is -1. Y2 is -1 here. Okay, minus y1, which is 1. Okay. All right. You gotta be careful with how we're working with negatives here. Okay, you gotta bring in some of that algebra knowledge that I know you guys have. Okay, so inside first 2 minus a -6. We got minus a negative here again. That means that this becomes positive. So that's going to be 2 plus 6. Okay, so 2 plus 6 is 8. And we're going to square that because we're squaring that from there. Plus, all right, this is now another level, another way of you having two negatives. We have -1 minus 1. A -1 minus 1. So you have a -1 and then you have another -1. So that's going to give you a -2. Okay. And then we're going to square that too. It's a good thing we have this squared because it does something nice for us. It gets rid of these negatives. So 8 squared is 64 plus -2 squared. That's -2 times -2, which is going to be a +4. Okay, so this is going to be the square root of 68. The square root of 68, okay, is approximately 8.24. Okay, it is approximately 8.24. So the question is this half of this? Is MN 4.12 half of 8.24, right? That's what we're trying to show right up here. Is it half? Well, let's take a look. Okay. If I take 8.24 and I multiply it by a half, do I get 4.12? I do. Okay. So MN is equal to half of JL. Okay. So you now know how to show if they're parallel to each other and how to show if their distances are half of each other. Okay. So now we got to move on to our triangle midsegment theorem. Okay. Our triangle midsegment theorem tells us two things about the midsegment. Tells us two things about the midsegment. Okay. It says the segment connecting the midpoints of two sides of a triangle, right, aka the midsegment, is parallel to the third side. Okay, it is parallel to the third side, and it is half as long as the third side. Okay, it is half as long as the third side, aka what we just showed here, right? Our midsegment MN was parallel to this third side JL, and the length of MN was half of the third side, which was JL. Okay, so we just showed all that. So what does this mean? Well, if I have a triangle like this, and it has my 3 midsegments in there, which one is the third side, right? Which one is the third side to each of these midsegments? So I'm going to use colors to show you. And we have midsegment AB. Midsegment AB is parallel to and half of this third side of GJ. Okay. That's the first one. Second one here, midsegment BC. Midsegment BC is parallel to and half the distance of the third side GH or HG. And lastly, midsegment AC is parallel to and half of the distance of HJ. Okay. Which also means something beautiful. Okay. Since each of these midsegments, right, connect these midpoints, okay, you still have from the very top, you still have this congruent to this because A is the midpoint. Oh, sorry. You still have this congruent to this because B is the midpoint. And you still have this congruent to this because C is the midpoint. So you have a lot going on here. A lot. Okay. So let's take a look at a quick example in identifying our parallel sides and our congruent sides here. Okay. Here's even something better. Okay. Here's something even better, guys. Since this is congruent to this, and each part is half of the whole, if this is half, and this is half, and the midsegment is half, right? If this is half of this, if this is half of this, and our midsegment is half of this, then they're all congruent to each other. So this segment GA is congruent to AH, is congruent to BC. Okay. Similarly, for our pink one, this is half. C is the midpoint, so this is half and this is half. So that means this is congruent to this half and this half, because they're all half of the same third side. Okay, and you got that same thing in the blues. 1, 2, 3 here. We got 1, 2, 3, and 1, 2, 3. So this half is congruent to this half is congruent to this half. Okay, this is a beautiful thing that happens when you have that mid-segment triangle, where you have all 3 mid-segments in there. Okay, it's a beautiful thing that happens. So if we come to our example here, okay, it says in the diagram, xj is congruent to jy. Okay, xj, I want to pick a color that's bright. Xj is congruent to jy, so this is congruent to this. YL is congruent to LZ. YL is congruent to LZ, so this is congruent to this, and xk is congruent to kz. So xk 1, 2, 3 is congruent to kz 1, 2, 3. Okay. Why is this important? Why is it important that we know that these parts are congruent? Well, that tells us, actually, let me move it down this way and move this here. There we go. That tells me that J is a midpoint. That tells me that L is a midpoint. And that tells me that K is a midpoint because they're in between. They're right in the middle of two congruent halves. Okay, so we have a bunch of mid-segments here. We have mid-segment JK. Okay, we have mid-segment JL. And we have mid-segment KL. Okay, so we have a bunch of mid-segments there, which means we have stuff that are parallel and we have stuff that are congruent and all that wonderful jazz. Okay, so if we take a look here, we have JK. They want to know what JK is parallel to. Here's JK. Okay, well, JK is connecting this side and this side. That's JK. So our third side to JK is YZ. So that must mean that JK is parallel to YZ. See how they're not touching at all? But JK is touching this side and this side with J and K, right? So JK is parallel to YZ. Okay. What about JL? Let's take a look at JL. Here's JL, right?
What is that letter in the far right corner of the triangle?
This one? This one? That's Z.
Got it. Thank you.
Yeah. Okay, so we have JL right here, right? What's the third side to JL? What's the third side to JL? When did heaven try to come in? All right. Okay. Our third side to JL is going to be XZ right here. So that means JL is parallel to XZ. Forgot to put segment there. Okay. What about C? I want you guys to give me C. Okay. XY. What is XY parallel to? Here is XY. Which mid-segment is XY parallel to? I want you to give it to me in the chat, please. Good job, Maya. Oh, and Caleb, thank you. I didn't see that you'd answered my initial question. I appreciate that. Caleb, try again, hun, for this second one. Okay, XY. What is XY parallel to? Which mid-segment is XY the third side to? Andres, hun, nope. You guys are giving me sides of the triangle. Pay attention to this, guys. They're giving you the side of the triangle. They're giving you the side of the triangle. They're giving you XY, right? This time they want the mid-segment. So what mid-segment is XY parallel to? Good, Mariel. Come on, guys. I want participation. Okay, Mariel, hon, I want you to relook at your letters, hon. Caleb, good. Gabriel, I don't know. I don't know what you're typing, Gabriel. Okay, so we should have that the side of the triangle XY is parallel to our mid-segment. So the mid-segment is not touching. You see how this mid-segment, J, and this mid-segment has J, and J is on XY? We want the mid-segment that's not on XY, which is this guy right here, LK. Okay, so XY is parallel to LK. Okay. Now, since we know they're parallel and which mid-segment goes with which side of the triangle, it means that we also have a bunch of congruences here. Okay, so let's start with our very last one. We're just going to talk about it in the diagram real quick. Okay, if LK is the mid-segment and it's the third side is XY, that means that XJ, JY, and LK are all congruent to each other. Okay. Similarly, if JK is parallel to YZ, okay, if JK is parallel to YZ, then that means JK is congruent to YL and LZ. It's a little hard to see, I know that, guys, with the congruence marks, I know, okay? And thirdly, if JL is parallel to XZ, that means that JL is going to be congruent to XK and KZ. So this is 3 congruences to match those 3 right there. Okay. So when we write these statements here, we can write JY here. Here's JY. Okay, so they're starting off with this one. So we're going to, oh, sorry, you can't see that. Here's JY. We're starting off with JY. So we're going to write down the other 2 segments that JY is congruent to. Okay, well, JY is congruent to XJ. I see those, right? XJ and LK or KL. Okay. JL, let's take a look at JL now. JL is right here. It's J to L. Well, they're giving us the mid-segment. JL is going to be congruent to that guy and that guy. Okay, so JL is congruent to XK and KZ. And last but not least, we have JK, and JK is congruent to YL and LZ. Okay. All right. So now that we know there's a bunch of parallel stuff and a bunch of congruent stuff, we want to actually add in some problems where we're going to be solving for some missing values. Okay. So in 3, 2, 1, flipping over. And we're going to do some quick math here. Okay, we're going to do some quick math. So it says AB, we're given AB is equal to 10.2. In the diagram, AB is equal to 10.2, MP is equal to 5.6, okay? And the measure of angle CNP is equal to 29. So I'm going to ignore the angle one real quick. We're going to look at the sides very quickly. Okay, we're going to look at the sides real quick. And so let's take a look. AB is 10.2. Here's AB. A to B is 10.2. MP, M to P is 5.6. Okay. They want some measurements from us. They want to know what is NP. Okay, what is NP? Well, NP is this guy right here, from here to here. Okay. NP is the midsegment of AB. Look, there it's the third side. Well, if NP is the midsegment of AB, that means NP is half of AB. Right? NP is going to be half of AB because NP is the midsegment of AB. And I know it's the midsegment because P is the midpoint of BC. It's cutting these two in half. And N is the midpoint of AC. It's cutting that in half. So NP is going to be half of whatever AB is. Well, AB is 10.2. So half of 10.2 is going to be 5.1. Okay. All right. So next we have AC. What is AC? Okay, well, let's see. AC is from here to here. That's AC. AC's midsegment is MP. I know that MP is 5.6. Okay, I also know that since MP is the midsegment for AC, I know that MP is equal to half of the third side, which is AC. I know that MP is equal to half of the third side, which is AC. I know MP is 5.6. So that means 5.6 is equal to half of AC. Okay, so how do I get AC by itself? I can multiply both sides by 2 to get rid of that fraction. And that will cancel that. And 2 times 5.6 is going to be 11.2. So that means AC is equal to 11.2. So there's two ways you can think about this. You can think about it as your midsegment is half of your third side, or you can think about it as your third side is double your midsegment. No, 5.6 times 2 is 11.2, hon. Okay. What about NC? I want you guys to give me NC. What is the length of NC? Let's see how many of you guys can get that. Length of NC. Given that your midsegment is MP, what is the length of NC? I want you to write it in the chat. I'm looking for participation. Okay. This one actually does not require a formula. What is NC, guys? Remember, our midsegment is congruent to the two halves of our third side. Our midsegment is congruent to the two halves of our third side. So each one of these halves is congruent to each other. Okay. Samson, great job. Mariel, I think you need to look at NC, right? AC is 11.2. A to C is 11.2. I want to know NC. Okay, where you guys at? Come on. This is not a tough one. Not a tough one. I'm literally giving you the answer, guys. The mid-segment is equal to the 2 halves of the third side. This is equal to this, and this is equal to this, and this is equal to this, and that's equal to that, and that's equal to that, and that's equal to that. They are equal. All of them are equal. Not a tough one. Thank you, Gabriel. Thank you, Maya. Okay. Let's see. Mark Maya is participating. Okay. So yes, since NC is congruent to AN and the mid-segment here, NC is 5.6. You could have also thought of this another way. If AC, if all of this is 11.2, N is the midpoint, cut 11.2 in half. This is 5.6. This is 5.6. Okay. We're not going to be doing the angle one. Okay, I want to do this one right here. I want to do this one right here. It says DE is a midsegment of triangle ABC. Find AC. DE is a midsegment of triangle ABC. Find AC. Okay, DE is a midsegment. This is a midsegment right here. That tells me a lot of things. Number one, it tells me that D is the midpoint of BC. So what does that tell me about BD and DC? Extra credit for the first person who gets it right in the chat. Thank you, Mariam. Extra credit to the next 3 people that respond. Mr. L. Never mind.
Did I mess up? I did. Did I? No, I didn't.
Well, you sent the answer.
Did I really?
Yeah.
Please forgive me, please.
That means he gets extra credit. And because he's a
Does
teacher,
get
he
extra
get
credit.
stickers
Good
and stuff.
job.
I need it. I definitely need that extra credit.
Yeah, so if D is the midpoint, it cuts the midseg, it cuts it in half, right? So therefore this is congruent to this. I'm taking this very slow. Very slow. I've been saying the same thing for the last hour and a half now, guys. Literally have repeated myself probably for the 50th time today. It also means E is the midpoint of AC. What does that mean about AE and EC? What does that mean about AE and EC? If E is their midpoint, what does that mean about AE and EC? They are congruent, yes. That means this guy is congruent to this guy. So if AE is 4.8, what is the measure of EC? If AE is 4.8 and it's congruent to EC, what is the measure of EC? What's the length? I want to hear from someone I haven't heard from like all day, but they say they're here.
They are congruent. That means identical.
Yes, it does. Let's see here. Joshua, what does that mean? Thank you, Kayla, by the way. What does that mean? If AE is congruent to EC and they're the same, what's the length of EC? Joshua, are you there? Thank you, Joshua. Yes, it is 4.8. Thank you, Zavon, as well. You guys, you have to participate so you guys can learn, man. It's not going to come out of thin air, and you need to let me know that you're participating so I know. Oof. All right, so yes, that means this guy is 4.8 as well. So if I want AC from here to here, all I have to do is add these two, right? So AC is going to equal 4.8 plus 4.8 for my two halves there, which will give me 9.6. Okay, so AC is just simply 9.6. All right. Okay, we have 8 minutes. And I kind of want to do, I don't want to do example 3. You know, kind of we can skip example 3. I actually want to do example 4 because it's a real life problem. Okay, it's a real world problem. Yes, I know it's kind of far-fetched real world, but it's a real world problem. Okay. We have a situation here. It says Pear Street intersects Cherry Street and Peach Street at their midpoints. So Pear Street intersects Cherry Street and Peach Street at their midpoints. Your home is at point P. Here's your home right here, point P. I just made that a lot darker. My apologies. Point P. Okay. You leave your home and jog first down Cherry Street to Plum Street, over Plum Street to Peach Street, up Peach Street to Pear Street, over Pear Street to Cherry Street, then back home up Cherry Street. Okay. The question here is approximately how many miles did you jog? Round to the nearest whole mile. Oh boy. In order to know how many miles you jogged, you need to know the distances of all of this, right? Okay, so we know Plum Street. Plum Street is 1.4 miles. Okay. We know that Peach Street from your house to Plum Street is 2.25 miles. But we have a midpoint here, so we can actually split that in half, right? And each one of these can be half of 2.25. So half of 2.25 means that this guy here is 1.125. And this guy here is 1.125, just so that we know the halves, right? Okay. Now from your house to halfway to through Cherry Street is 1.3 miles. So that means that since this is a midpoint, what's the distance from this midpoint to Plum Street? What's the distance from this midpoint to Plum Street? If this half is 1.3, what's this other half? Anyone? Okay, thank you, Gabriel. Can I get 2 other people to respond? I want 2 more people. Let's go. If I don't finish this by the end of the period, I'm keeping you guys. We're not leaving until we finish this. Thank you, Samson. Thank you, Maya. All right, well done. If this half is 1.3 miles, then this half is 1.3 miles. Okay. All right. So now let's trace our path. Let's trace our path because it's a very convoluted path. Okay. So you start at your house. Yes? You're going to go down Cherry Street all the way to Plum Street. So down Cherry Street all the way to Plum Street.
Did you go down Cherry?
Wait, oh crap, we do. Okay, another color, thank you. Hold on, I think I got a silver one up in here. Oh, I do not. Sadness, okay. We're gonna make it work, guys. Okay, we start at your house. We're gonna go down Cherry Street to Plum Street. I can't believe I made that mistake. Not gonna lie. We're gonna go over Plum Street to Peach Street. So over Plum Street all the way to Peach Street. We're gonna go up Peach Street to Pear Street. Up Peach Street to Pear Street. Over Pear Street to Cherry Street. So back this way. Then back home to up Cherry Street. So back this way. Okay, so we gotta get all this mileage in, right? So all the way down Cherry Street means we went 1.3 miles and then another 1.3 miles. So we have 1.3 plus 1.3. That's just the Cherry Street, right? Actually, I'm gonna do it right here. That's all the way down Cherry Street. And then we went over Plum Street to Peach Street. So that's gonna be 1.4 miles. Up Peach Street to Pear Street. Okay, so that's gonna be our 1.25 miles. Oh, 1.125 miles. Apologies. Okay. Over Pear Street. Oh, look at something we did not calculate, guys. Pear Street is our mid-segment here. And it's going to be half of Plum Street. Okay, so half of Plum Street is what? Half of 1.4 is what? It's going to be 0.7. Yeah, there you go. Okay. So it's half of Plum Street. Pear Street is half of Plum Street. So this is going to be 0.7 miles, right? Half of 1.4. Then back home up Cherry Street. So then we're going back up Cherry Street, which is going to be your 1.3 miles. Okay. Now we're going to add all of this together. Oh boy. Oh, look, my gold got. So we have our 1.3 plus 1.3 plus 1.4 plus 1.125 plus 0.7 plus 1.3. We're going to add all of this together. 1.3 plus 1.3 plus 1.4 plus 1.125 plus 0.7 plus 1.3. 7.125 miles. It says round to the nearest whole mile. Okay, using that guy, rounding to the whole, that's approximately 7 miles. So approximately how many miles did you jog? I jogged approximately 7 miles. And at the end of that, I'm going to say in my dreams, because that probably will never happen. For me personally. So you have an exit slip, ladies and gentlemen. Okay. I want you guys to really take out your notes. Okay. Use your notes on it. Do your best with it. Do your homework on big ideas and then do the exit slip. Okay. You might have a substitute on Wednesday. I'm not 100% sure yet. Okay. But they will be teaching a lesson, so make sure that you guys are here. You don't want to miss that lesson, okay? Other than that, guys, great job. Thank you for those of you that participated. I'm proud of you. And I will see you guys on Wednesday or Friday. We'll see. Okay, take care.
Bye, guys.
Bye. Bye-bye.